Welcome everyone to this new MLIR meeting. Today we're not having a tech talk. We're going to have a discussion and a review of an RFC about TCP, this high-level dialect. And Raghavan has a proposal about how to handle broadcasting. So Raghavan, the floor is yours.
Yeah, thanks a lot, everyone. I'm Raghavan from the ML compiler team at Cruise. So we're going to be talking about broadcasting in TCP today. We sent out an RFC a couple of days back, the document that describes the RFC in full detail. Today, I'm going to be presenting a summary, and then we can open the group for discussion and take it from there. And first of all, thanks a lot for all the comments in the doc. That has been very helpful already. So let me get started with the summary. Okay, so we propose to have explicit broadcasting in TCP, and that is proposed to be specified using a TCP.broadcast op. Let me get into the semantics of the broadcast op itself. So it'll perform DIM1 broadcasting only. It doesn't perform rank broadcasting. That is, there are no changes to the rank done as part of this op. So any change to the rank has to be done by reshape ops prior to broadcasting. And this op has these constraints where the broadcasting access, whatever access that broadcasted on, must be statically known. And also the input tensor's size along the broadcasted access must be statically known to be 1. And this last constraint is specifically to avoid dynamic 1 broadcasting, to catch those cases and error out, right? And also, I mean, the broadcasted DIM, the size that is broadcasted to can be dynamic, of course. So I'll get to an example once I present the spec. So this is the op spec itself. So the op takes in one ranked tensor of any supported type and a variadic number of scalars of index type, and returns a ranked tensor of the supported type. And also it takes in an attribute, which is basically the list of access that are broadcasted from the input to the output. Right, and we're using index type for the DIM sizes as well as the access numbers. So let's look at an example. So this is showing an example from how we lower a front-end op with implicit broadcast. In this case, we are using torch.add as an example. So a front-end op with implicit broadcast, how does it get lowered to TCP? So in this case, we are adding two 1D tensors, one with size 1 statically known. The other is a dynamic size tensor, 1D again. So in order to do this, we'll broadcast the first tensor, but get the size from the second tensor and broadcast it on the broadcast that to the dynamic size, and then add those two tensors again. So the next example is slightly more complicated. So we are in this case we are trying to add two tensors of different ranks. So first is a 1D tensor and the second is a 2D tensor. Both are all the DIMs are dynamic. So the way this gets added is by appending a 1 to a leading dimension on the first tensor and broadcasting that. So we make everything explicit in the sense that the appending of 1 is done by the tensor.expand shape op as highlighted. And then we have the same case as before, where we are broadcasting on the first dimension from 1 to the dynamic size. And then we add the two tensors of both of the same shape. And note that we haven't added the assertion here. That is the design for the assertion is to be TBD. So, but this will include an assertion to check that the first DIM or the DIM 0 of in1 is same as DIM 1 of in2. So if you have any questions, we can take it now, or I have a couple of alternate design choices that are listed here. We can go over that and then have the discussion. Okay, so let me go over that. There are no more questions. So one alternate design we considered, which is pretty close to this, but slightly different. I'll go over the differences. So the proposed design initially is just not do, it doesn't, the TCP broadcast does not do any rank broadcasting, but in this alternative design, we propose to like say, we can do a rank 1 and dim broadcasting, but the rank broadcasting and rank and dim on broadcasting, but the rank broadcasting is restricted to NumPy style. That is, it'll only add once on the leading dims. So the TCP, this is only restricted to the TCP.broadcast op itself. So for any other rank broadcasting where you add ones to the non-leading dims, we have to do a reshape like what we do now with the expand shape. So this is one design we considered. I'll show an example, a couple of examples with this design as well. So same as the last example where you are broadcasting on the leading dim. So in this case, we will not have an expand shape, but rather have the broadcast itself expand from a question mark to like a question mark, where it adds 1 to the leading dim, and then rest is the same, right? So so one advantage of this design is that for the common case of where the broadcasting is on a leading dim, we will not have a reshape. So, but for the case where you're broadcasting on a non-leading dim, I'm using static shapes just to make things clear. So here you want to convert from broadcast from 20 + 8 to like 20 question mark 8. So in this case, you will have to add a reshape to add the 1 dimension in the middle, and then you do a broadcast. So this is so for this option, the benefits are it's going to simplify the lowerings from front end because we don't need a reshape for the most common case, which is broadcasting on the leading dims. But and also it's going to you don't have to avoid when you're doing if you want to do pattern matching for broadcast, you don't have to match for the expand shape in the most common case where you're broadcasting on the leading dim. But the drawbacks are now rank broadcasting happens in 2 different places, sometimes in a reshape, sometimes in broadcast. And also that TCP.broadcast itself changes the rank in some cases, but not all. So these are the disadvantages of this design. This is pretty close to what we have, but we are okay with either way, but we are still proposing the initial design that I presented, where everything, all the rank broadcast is separated out. So the
question.
Go ahead.
Comment in the chat.
Oh, sorry, go ahead. I didn't. I don't have the chat open. What is the question?
I'm going to read it out loud. If Nicolas cannot unmute himself, he said, "I don't see the need for 2 different ops, but I see other drawbacks." Maybe Nicolas, if you want to elaborate on that.
Yeah, sorry, I don't have a root, so I will just speak like this. So let's see. Could you go back to your previous slide, please?
So looking at the first example here, or
right at this example. So I'm not sure why this has to be broadcasting in a leading dim. I think the axis, if you interpret it as the dimension in the destination tensor into which you broadcast, I think that fully specifies any dimension broadcasting. It doesn't have to be leading. So I think axis is a bit more general.
So
yeah.
I mean, okay. So first of all, I think the torch.add semantics is that it's going to append 1 to the leading dim on the tensor with the lower rank, and then add it, right? So that's the semantics that I'm trying to represent here.
Well, it doesn't technically add the dimension. It's more of a sort of convenience to align the ranks of the 2.
Right, but the how it works is like that, right? By appending it.
Right.
That's what I meant.
Yeah, so that I understand, right? It's like, okay, yes, if the torch does broadcasting on a leading dim, you can represent it with axis equals 0. Yeah, no question.
Yeah, so that is the case this example represents. The other case is the second example here, where you want to specifically broadcast. I mean, I don't have like a front end op here, but just saying that you want to broadcast on a dim in the middle, not in a leading dim. Then we do left to insert a reshape here.
That I don't agree with. I don't think you need a reshape. Like the TCP broadcast with axis 1 is fully specified.
Okay.
It goes from 2D to 3D, and you just say, basically, you know, if you look at your first, at your commented outline, it says you go from 20 by 8 into 20?8. If you think of axis as the dimension of the target in which you have that you have broadcasted, it's fully specified without any for reshape.
Axes isn't specifying to insert a dimension there. It's saying that you're casting that dimension, right?
Yeah. So in this case, it's clearly saying just the dimension that's broadcasted from the input. I mean, Nicola,
Right.
I'm just trying to understand it. I mean, it probably looks simpler because I have static shapes, and that is just for reference. I mean, if you have fully dynamic, is it still specified? I'm trying to understand that.
Yeah, I think so. You can go from question mark into, like, from 2 question marks into 3 question marks. And if you say axis as being the dimension of the output tensor that has been broadcasted, then you can put, you can put axis 2, 3, 4 if you want. And then, yeah, I think it's fully specified. I don't see any issue.
No, the problem is there are cases where the ranks of the 2 tensors will be the same, input and output, but in some cases the ranks of the tensors may not be the same, like the previous example here, right? So in this case, the ranks of the 2 tensors are not same. So how do you differentiate between these 2 cases?
I mean, here you could basically broadcast by saying broadcast along 0 or along 1. And then basically, if you broadcast along 0, it means that dim 0 of output tensor is %0. If you broadcast along 1, axis equal 1, then you say dim 1 of the output result tensor would be %0. That's roughly how Linux would represent it.
Okay, okay, I'll have to. I'll have to think of some case. I don't know exactly which what other drawbacks this would have, but okay, we felt like, okay, let me present the other option, the second design point, that alternate design that we had. Then we can take it from there, Nicola. So
right. I could mention, sorry, if you don't mind,
right.
I could just mention the drawback that I'm seeing to what I'm saying.
Mm-hmm.
The biggest drawback I'm seeing is that it's likely the expand shape can canonicalize and move around better, rather than having a broadcast op that has, like rank increasing semantics, and that needs a bunch of other canonicalization patterns and other things to work properly with the system.
Right.
That's the biggest drawback I'm seeing.
Oh, okay. Yeah. So you're saying that the original design that we have, which is basically expanding, using expand shape for all the rank broadcast, followed by a non-rank broadcasting TCP broadcast, is better.
It's a trade-off. So I think the positive aspect is that the expand shapes are probably going to behave better in the system and move around more easily. If you don't insert the expand shape, then you need special things on the broadcast that has expanding semantics by itself. So it's really a trade-off between, do we want to use expand shape or not? And what is the most pleasant semantics? And I don't have an answer for that. I'm just giving options.
Okay. Yeah, I mean, one argument I've heard from several folks in the community is that tensor.expand shape itself is more powerful than the particular use case that we are using here for. Specifically, we are expanding one dim to like multiple dims where everything else is ones, right? Nothing is dynamic, right? So there is actually at least some thoughts that this is we are using it in a restricted setup. So is it the right way? So I just wanted to put it out there.
I just want to check that Mahesh's question, the chat has been explicitly answered.
So what is that? Sorry, that open.
It says that the design of the slide, the final design, or considered alternative.
No, I missed that.
I'd say it's an alternative word since we're discussing it.
Okay, so this design is the design we are proposing, where there is basically this one, this it only performs DIM1 broadcasting and there's no rank broadcasting. This is the design we are proposing. But we did consider two alternative designs, which is the first one is this, where the TCP.broadcast performs only a numpile style rank broadcasting, that is rank broadcasting on the reading DIMs only. So, okay, let me finish up the rest. So the second design option we considered was to have TCP broadcast perform both rank and DIM1 broadcasting, any arbitrary rank broadcasting here. So for this, we feel this is probably where Nicola will probably disagree. We feel that there is a need for this something like reassociation that's taking from, I mean, exactly what tensor.expand shape does, maybe in a restricted form. So something that expands the input tensor to the output tensor shape and then presents which axes are broadcasted. So just combining the two ops semantics together. Right, but there's one other thing extra we need to check here because we are checking for static ones on the input DIMs and because we want to avoid dynamic one broadcasting. So for this example, where we are going from say $1 to like $, 3 question marks. So one of the broadcast, and we are broadcasting on two DIMs here. So one of the broadcasted DIMs comes from the input, the other comes from the reassociation. So we'll have to make sure that the one that is coming from the input is statically 1. So that's an extra check that we need to do. So, and for this case, we feel like, I mean, again, the benefit is lowering from front end would be simpler. But we'll have to, the drawback is we'll have to redo the semantics of at least a restricted form of reassociation in TCP broadcast. And I mean, because we are combining the two, the semantics is going to be slightly more complicated because we'll have to make sure that the check I specified how do you check the input dimension, which input dimension is broadcasted, if it's 1 or not, we need to add that check. So yeah, that's right. So that the first design is the proposed one and the two alternatives we considered. So those are listed here, and I believe this is my final slide. So these are open questions, scalars versus rank 0 tensors. We've had to make some assumptions, but these are still open. For scalars and rank 0, current assumption is for metadata, we're going to use scalars, and for data, we'll use rank 0 tensors. And for index versus signless, this question has come up as well. So the current assumption is for access numbers and dimension sizes, we'll use the index type. And shape guards is open. We've heard strong opinion against using shape dialect for this. So one other alternative we are considering is to have like a TCP assert, which will check for which will just assert if the shapes are not equal.
Quickly, Dale, there's some feedback from Nicholas.
Yeah. Okay.
It's in the chat. Mehdi, would you like to?
Yeah, I have it open now. Sorry. Yeah.
Yeah, just for the recording, Nicholas was saying that the provenance of the broadcasted DIM shouldn't be relevant. So if you can go back, I think it's about this alternative design 2 here.
Design 2. Okay.
Yeah, this one where you were saying that one of the, I think you can go to next slide.
The next one. Yeah.
Yeah, and one more so that we see your annotation.
Oh, okay. Yeah. Yeah.
That's it was saying that it should be irrelevant that the axis 2 comes from the input or not here.
That is if you check after reassociation, if you split this up into 2 steps where you perform reassociation and then check, right, then it's irrelevant, right? You can always, because by trivially it's going to add 1 and it'll always be true for these 2 cases. But
so if we swap, I guess the question Nicholas was saying is that from his point of view, there's no semantic difference if you change the reassociation to be first the 0 alone and then 1 and 2 together, right? If you change the inner brackets to group them differently.
Yes, that's true. I mean, I'm just saying if it's specified this way, and if you want to perform the check of like the static 1 check, we'll have to look for the specific input dim that is broadcasted and not the ones that is created from reassociation. But if you say that we'll split this up into 2 steps where you say, okay, we perform reassociation, however that is, so that will give you the full rank tensor with ones in it. Then do this check of static one. That is okay. That makes sense. Then it's trivial. But yeah, you can specify reassociation in two different in another way, as you said, like 0 and then 1, 2.
Oh, I mean, hey, so I think so we're just trying to interpret what Nicholas is saying here, but Nicola, correct me if I'm wrong, but I believe what he's saying is that we can just remove this reassociation thing from TCP broadcast because we don't really need it. We just need to know which output axes are broadcasted. And that's enough for us to, because we're only introducing dimensions in the output that replicate the input. So it's not, if we kind of write it out as like literally as a for loop, we'll see that we can write it we can implement it in a way that doesn't need to look at reassociation. It just needs to look at what output axes are the broadcasted dimensions. So, I mean, I think we'll have to work it out on pen and paper a little bit to see if this implicates our design, but that's a very good insight, I think. Maybe some of these things are not quite as complicated as we think.
Yes, Nicholas says axes and ones are redundant. Okay.
I think so. So if I understand correctly, it comes from the fact that you statically requires the 1 in the input type. Is that where the redundancy comes from?
Yes, sorry, I'm having a bad room situation here, but yes, that's kind of the idea, right? Like it's like axes and the presence of ones in the input are redundant. Like it doesn't mean we shouldn't have it, but I'm just saying that information is redundant. So adding the reassociation in addition to that is really becoming very complex for nothing, I think. But this is just a alternative design, so I don't think it's being seriously considered. But yes, I think with just axes, either with axes or with ones that become something else, there is enough information. You don't even need both.
No, actually, Sanjay added a comment for that. There is a case that if you remove the shapes, and probably Sanjay can answer better.
No, I mean, I think that is slightly different from what. So yeah, that is a different concern. I think in this case, I mean, I guess if you just know the output axes that are being broadcasted, then we could implement it as you squeeze the input, and then you add the output axes, and whatever's remaining, you again insert a degenerate 1, or some kind of an implementation like that could work here. But I think maybe there are others also, like Mahesh, who maybe want to discuss the thing that we are proposing a bit more before we kind of dive deep into the alternatives. I'm wondering if that's more productive.
Yeah, so maybe we can go back to the actual proposal, because yeah, as we said, we spent some time on the alternate.
So
and just maybe recap what are the 2 up you're proposing in there.
Yeah. Okay. So in the proposal that we have, the broadcast op only performs dim1 broadcasting and no rank changes. So the examples here. So this example is like when you have the same rank on the input and output. And so in this case, we'll just have a broadcast, no reshapes. We don't need a reshape. But in the case when the rank of the input and rank of the output are different, so we need a reshape to add the 1 dimension whichever position you want that in, and then broadcast that tensor. So this is the design we are proposing. So okay, first question for the community is like, is it always better to like separate out rank broadcasting and the dim1 broadcasting the way we have proposed? Are there any concerns for that?
have we, for this, I would ask, have we listed the pros and cons of both in the doc, maybe?
No, I mean, okay, so the drawbacks are, again, this is the ones that are listed here, right? Like this is compared to the proposed design, right? So that's what we are saying.
Right, so I could maybe comment here. Basically, there is another place where we have these ops that have both rank reducing and rank expanding semantics in addition to their semantics. It's these subview or tensor insert extract slice, where basically you can take some slices of one and drop the dimension that becomes a one or inject it. And the experience there, I mean, my personal experience has been that it's very, very useful to be able to canonicalize and fold without having long chains of operations. So basically the rank reducing extract slice, for instance, says take a 3D tensor, take a slice that is something like 1 by k by 1. It can become a 1D slice immediately. And that's pretty powerful because it just lowers down to index arithmetics in different ways, and it really cleans up the IR. So that's one, I guess, part of the trade-off. The other part of the trade-off is, yes, more complex op, more difficult to implement, a bunch of other trade-offs kick in.
So like IR verbosity, right? Like, is that like one way to summarize the benefit of this option one?
I mean, it's especially, so IR verbosity is one thing, but it's especially that when the IR verbose, because you like when ops don't combine and you actually need 3 or 4 ops to express the pattern of rank reducing things, then you have to be aware that anything that requires detection of that particular pattern now needs to go and look for 4 ops, right? So like having everything in one op and saying, oh, is this something that reduces my rank from 3 to 1, then matvec, for instance. That's pretty powerful.
Okay, yeah, I think Mahesh has his hand up.
Yeah, sorry, I had some technical difficulties. Finally, I was able to get onto my machine. Can you guys hear me?
Yeah.
Okay. Yeah, I think that's all the discussion that was happening before this was proposed, like having the expand shape to add unit dimensions explicitly to represent the broadcast. I think it came down to kind of this is what the front end does. So having one way to represent the broadcast. So it's about where do you add the complexity. If your input language is going to give you this unit dimensions as a way to represent the broadcast, then when you lower into TCP, you have to kind of resolve those complexities away to get it to a stage that doesn't have those extra one dimensions and the expand shape. Or you can have TCP be a more easy representation, something that can be easy to lower to, and then post that at, for example, at the lineage level, we can already do this. There are already passes that we have that can drop the extra dimensions, collapse it away, and kind of it undoes this. So it came down to where do you manage that complexity.
Okay, so what I hear is like from from Nicolas specifically on the rank, rank reducing or rank expanding thing with the broadcast, that has good trade-offs. So are there any any strong suggestions either way to go with that or separate it out? Are there any other points on that?
I mean, perhaps one question here is, so like in terms of these two designs, I think the going from the current proposed one to the alternative where you allow the rank change, that would be a drop-in extension, right? Meaning like if you had the original one before, after change, what was legal before would still be legal. So basically, it's the question where how expensive a change would it be if we chose one route and after evaluation with data from the front end and targeting and then looking at the transformations, we'd have to change.
Okay. So you're basically deferring it, trying to use trying to start with the most complicated version, and if it's too much, you're saying we can dial it back to the proposed design. Is that what you're proposing?
No. I think I'm more saying, like, if we're unsure what is this, like, what is the cost? I mean, this is not fixed, set in stone. Like, this is something that can change. I'm sort of like saying, if you start with the more conservative one, you know, it may be easier to extend it, but you know, I'm sort of more just saying, like, can we get a bit more, potentially an option here is to get more data to help guide a decision and guide evolution here, rather than, you know, just without connecting to the front end and how it fits in and evaluating it, you know, getting to some fate. I think Nicholas's point is it's turned out very useful for him and in the transformation side to be able to do this, and that this duplication in capabilities he doesn't see as, I mean, not to put word in his mouth, but he doesn't see as necessarily like bad. You know, it's not something that is that heavyweight. But yeah, I'm just trying to figure out in terms of, like, I don't know if we're getting this meeting, we'll be able to come to, you know, like a final state just without more additional like anchoring to what's actually happening.
Yeah, that's a good point. Like we should be able to switch. I feel like we can start with one of these designs, like maybe the more complicated one, and then switch. It shouldn't be.
Raghavan, I think Jack is suggesting starting with the simpler one. That if we move to a more complex one, the input IR that was presumably generated, all of that stuff still remains valid, but it becomes more expressible because we can accommodate more. I mean, that sounds fine to me, but the place that will have some churn if we do that is all of the pattern matching stuff and things like that we write initially. Now that's either dead code or has to change in some ways. But I mean, I would be fine with that. I think for us, the objective here is to not settle on the one true design, but settle it just enough so that we can start implementing things. And if it looks like the way to go is to start implementing the simpler thing first, and maybe circle back in a few months and say, hey, like, it worked out really well, or it really sucks and we need to change. I mean, I think that's a fine outcome for today. If we decide that, hey, let's start with the simpler thing, with the caveat that we may revisit it in a few months, I think that's fine.
Yeah, and to your point about like the pattern matching, I think the pattern matching will also give you indication of like the cost here of the simpler design. Like if it ends up that you're needing to do like a little bit of heroics there versus what you could do with the other format, I think that's a good indication of, you know, potentially needing a more expressive form.
Yeah, actually, just one clarification, Sanjay, that so if we go with the simpler form and if we say remove the expand shape, then it's not semantically correct, right? So I thought the other way is better, like starting with the complicated form, but if you insert expand shape, it's still correct. So that's why.
No, you would remove the expand shape, right? Like we would start with the simpler form, and the torch to TCP lowering would insert these expand shapes. And the broadcast is still doing rank preserving broadcasts. And then later we generalize TCP broadcast to also allow rank changing broadcasts. And that's fine because the previous integrations that you had with torch MLIR that generate the expand shape is maybe more complicated than necessary now because the expand shape is redundant and you could have generated a single TCP dot broadcast, but it's still correct. And we could potentially even have canonicalization patterns that pattern match that to the more optimum representation that takes fewer nodes to represent.
Okay. Yeah. Fair enough.
And maybe one way to frame the discussion is like, if we do this, like, are there any kind of strong objections to saying that, hey, we start with starting with the simpler version and then revisiting it potentially if it turns out to be too onerous? in a few months? Like, is there anyone who really wants to push back against that strongly?
A quick mechanical question about those simpler examples. It sounds like an extension of the data-driven approach here, the slide set. And what would be a good way to, for example, share what we learned from adding more examples? Could we post them on the Discord thread or something else? Any suggestions on that?
I mean, I think that sounds like a good idea. Basically, having the proposal, and as you get more, examples, experience, adding more things for folks to see, I think, would spawn up a nice conversation. So yeah, that sounds perfectly reasonable to me.
And as we add code, we'll also get standard code reviews. So like, I feel like the folks here would be in a good position to say that, hey, like, please stop and let's revisit the IR design because this is pretty bad.
Okay.
So it seems like that we're taking a bit of a learn and iterate approach, and that definitely makes sense to start from the simpler thing in that situation. I'm thinking back. Some of us have significant mileage on some of these things, and I'm thinking back to the number of times we messed it up and wish we hadn't added the kitchen sink first. So I think we can. Speaking for myself, like, as long as we're in a process where we are having this discussion and trying and iterating and trying to keep it to a simple basis, I'm personally okay with that. Am I reading the situation right? I'd like to make sure that we've got the right folks who feel comfortable expending the energy on review and teaching feedback engaged in this.
Definitely. I'm thinking here, and not trying to speak for everyone here, but at least my perspective was that we can make forward progress on designing other parts of the dialect while iteratively, through the iterate and learn process and broadcasting, expand the envelope and understand how the design looks like as we cover more substantial detail. And we can still have significant examples for other constructs that isn't load bearing upon the particular state of the broadcasting design at that point of time. So it can be at least reasonably decoupled to some extent, so we can make forward progress and not be entirely gated by this.
Okay, I'll just say I'm not sure we're completely converged on the best thing, but what I'm hearing is that if we're good going simple, and there's enough folks who feel comfortable engaging, to as we go, like, no objection from me.
I think the feedback from Nicholas in particular was really actionable and very helpful. Would it help, for example, if we reconsidered after meeting what the feedback was, incorporate that into the document and kind of say, this is what we think, this is what we have learned from the meeting, and sort of state, this sounds like a good place to start working on iteratively.
It would be good to update. It would be good to update the document. There was a lot of commentary and close out commentary threads. There was a lot of notes and stuff, so let's make sure that that we've actually captured what we're doing.
Yep.
This is just my opinion. I'm just speaking up because it seems like no one else is.
That sounds reasonable, I think.
All right. if that's the end of the broadcasting topic, is there another topic you want to talk about, whether it's about TCP or?
Actually, sorry, let me stop this then. So the other one we put out was the element-wise. If we have any comments on that, we can chat about that. If broadcasting is, at least the way forward for broadcasting is settled.
I mean, but perhaps one comment, and this is also on the slides, and this is sort of related. There was a question on like how do we do error checking? And I think that's something to make sure in terms of like how you position where TCP is in this entire section of the world. And so my current mental model is TCP is similar to LinAlc in the sense that these are both we are compiling a verified program. Like somebody else, front end, whatever, has done verification, inserted asserts, inserted whatever. We are in the compiling for something valid, section of the world. So meaning like the how error checking is done for me feels orthogonal to TCP. Like if we go for PyTorch, we might have a PyTorch insert. If we go for JAX, we may have whatever. If we go through TensorFlow, we may have a TF assert. Your goal, your positioning is we're optimizing very aggressively something that is valid according to the semantics of the object we've defined.
Correct. And yeah, that's right on that. And I acknowledge there was a discussion late last evening involving Mehdi and Mahesh, and I believe Sean, you had. And the thing is, we currently actually have at least partially done internal document kind of establishing how the different abstractions of the different dialects connect together. And I just haven't put that publicly. I'll try to do so soon because I understand that this is an important topic. So let me do that, and maybe we can continue the topic within discussion within the document. How about that? All right. We should be able to get it out within probably by the end of the week or early next week. Is that okay?
That's good. I think your document is even a bit wider than what Jack was saying, but it's a superset of that, right? You were saying you work on a doc about the positioning of TCP in the ecosystem, right?
Yeah. That's kind of the idea. The document is.
Yeah, that's great. I'm on the same line as Jack, by the way. That's my understanding of TCP. Mentioned.
So I guess so. This practically speaking, right? Like it means that operations like TCP.matmul should not throw user visible exceptions. That's just undefined, and someone else has verified that the matmul that you're doing is actually valid. So that's one implication. The other implication I was thinking was, does it mean that we should not have a TCP.assert? And if we don't, then how would we have a complete lowering from, let's say, torch to TCP? That is correct.
Yeah, I mean, I think that's a very good question. So I think in my mind, not everything goes through TCP, and so like even in this cogent section, this could be something where this assert is sort of a function of how you hook into whatever runtime or deployment you're at, right? Because, for example, like the PyTorch case, I have to give the error back to Python, to the user. In another case, it may be I literally throw an assert or I log an error to some remote server and kill my remote processes that are attached to this, right? So it feels like there's no one lowering for the safe check. I mean, having an assert itself is useful, but I feel like that it's a little, I don't know how to phrase it, but it sort of feels like depending on where I hook it in, I would actually want that assert to behave differently. And so I don't know what I would define the meaning of this and how it would be different than, for example, if we have in a control flow dialect, just a plain assert or whatever, so I mean, in some of these cases, we also had like lowerings where to add an assert, we effectively end up with a program transformation that adds an additional bool to the end result of the entry function and switches it through, which is a huge pain in the ass, but some cases it's useful.
What do you think think about the assert more in the JVM style of asserts? Like these are not these aren't for communicating user visible exceptions. They're they're meant for for safety guards that can only be added by the front end that's producing it in some fashion. I'm not stating this very well, but I mean, it seems like a reasonable tool in the toolbox, but the program is perfectly valid without it. It's perfectly valid to strip it, and you've got the UB and
yeah. Well, and I think the other thing I like about those asserts is sort of like it enables you to capture some of the state it's like Stefan and I were chatting about it once upon a time. Like it's sort of like assert versus assume kind of category of the world, where I'm capturing semantics that if I have an analysis or a front end could inject and put in additional knowledge. I think those are very useful.
yeah. I think that anything more semantically charged than that gets you into error checking territory and all that stuff is out of scope. It's it's somewhere else.
It's a different level, yeah.
From the front-end space, it seems there's a large diversity of what the front-end is capable of doing or will do. For example, in Torch, there's some kind of one-time assert operator, but there isn't anything like that, for example, in TensorFlow Lite. So what can be motivated from the front-end seems to vary widely, and we still want TCP to be able to both optimize and avoid entirely breaking the program flow because we didn't cancel some kind of UB properly.
Yeah, I mean, this is my personal opinion. I see this level of assert be valuable in the case of, like, as an example, if you're lowering from JAX and JAX has a well-defined type system for its that actually captures a fairly good shapes of things, then the asserts become just that. They are assertions against bad behavior that the front end can insert, and for contract violations. If it was invoked incorrectly, something got through the layer or whatnot. If you're inserting these kind of asserts for something like high-level user-facing TF assert, or to try to recover an error message of some kind from TensorFlow, which doesn't have a type system that constrains things, that feels like other to me. That, like, maybe we add assertions, to guard if we want to enforce safety, but it really is kind of a last mile check. Not sure I'm stating that particularly well. We've frankly debated this in various circles for years, so I know I'm just representing one slice of it.
I mean, from my perspective,
sorry,
I was going to say, from one thing that, from my perspective, I was also thinking of what is the minimum thing we need to add to TCP so that we can write complete lowerings from Torch to TCP. One way to do it is to say that, hey, Torch, if you have a torch.add that is adding that is incorrectly shaped, you just get UB in the lower program. That may be fine, but I suspect I suspect it would raise some eyebrows. Whereas if we had some very minimal thing like a TCP.assert that just takes an I1 and says, hey, if the I1 is false, then it does a non-local exit, then we can at least have a kind of correct lowering where at the very least the generated code doesn't misbehave. And anything more elaborate, you would have to hook into the PyTorch runtime or the TensorFlow runtime, as you
Right,
say.
exactly.
Yeah. So this is actually an interesting example. So because in the current PyTorch lowering, as far as I'm aware, they actually have explicit run shape guards at the very top of the function. So they have some of these constructs, and then it's a question like you're lowering maybe the things that are below this, So, but I mean, this is a good discussion once you get there. I think that's where like Torch MLIR, branch iterations is useful because you can see like literally what it produces, the shape guards and all these. And sorry, Stefan, I didn't see your hand.
Yeah.
Yeah, I, to some degree, I just wanted to restate some things that I think Stella said. So I think if you design something like TCP, you have to be very careful not to bake in too much of like PyTorch assumptions, in the sense that like the Jack's argument, right? You might have an input language that has a very strong type system, much stronger than what TCP has, what MLIR has, and you definitely don't want to get in their way by baking kind of type checking into TCP or TCP operations, right? So, but I think that's also not up for debate here. I think that definitely has to be separate, right? So that's where also the approach we're taking in MHLO with making checking like a separate entity, so that we can kind of support these use cases. If you just want to insert an assert so that we have a way to kind of bail out of your program, I would also not see this in TCP. So all the asserts we've created are in separate dialects depending on what framework you are in, right? So you can lower the PyTorch assert to some assert, right? Because it also doesn't have a lot of interaction surface with TCP, right? Once you assert, you're out, right? There is no, you don't care about the computation really. It's a very separate concept, I would say, right? So that's why I also wouldn't see this like as a TCP feature if it's not a compute thing in that sense.
I think that there is a desire for some front ends to even just in a degenerate mode to basically say, you know, we have a loose type system, and you know, add asserts please, you know, or something. Maybe those are front end specific ops. You know, it's just there's UB is strong, and sometimes you want to be able to turn on safe mode, even if you're saying we run programs that we run kind of thing. I'm not making a clear argument. I'm just noting that I've found a lot of things in practice in this middle space.
Yeah, you definitely want to have safe mode. My point is more like, so we have to build like a common denominator of all kind of input frameworks we anticipate on the compute level already. So maybe you don't want to make a problem even harder by doing the same thing in the context of constraint checking, assertions, error handling. Right. So by separating these two, it's just easier to find the one solution for all users if you concentrate on a domain. Maybe that's a way of looking at this as well.
Yeah, we do also have cf.assert. I do not sure it's defined right, and we've also discussed on and off for a long time that might be better modeled as an assert with or something, a functional assert instead of what it is, a side effecting up that doesn't return a result.
Internally, this conversation was motivated by questions as to whether the dialect operators should embed something that states that a particular kind of behavior is undefined or unanalyzable to the point where we cannot optimize things much at all. But yeah, we want to be covered first and then perform it next, because there's no point in breaking things fast. But we do not seem to have a good picture on what the lowest common denominator that we could implement would be.
Yeah, I think this sounds like a good topic for a full discussion as well. I mean, it's a big one. It's been going on across Stella's point, been multiple levels for multiple years, which makes it fun.
Congratulations, you guys. You know, some of us that have worked on some of this since the beginning have. You're in all of the conversations that never terminated. They just exhausted. So.
Yeah.
Right.
Perhaps just time check. We have roughly 1 minute.
Yeah, we're at time. So are there any follow-up action items you want to call out, Raghavan? Are we good?
So I'll put out a summary first and resolve the comments in the docs, open comments, and put out a summary like we're going to start with this simpler one and then iterate down the line. And we'll keep updating it examples if we find any corner cases that doesn't work. we can update the discourse thread that way.
Fantastic. Awesome. And I'm looking forward to Suraj also look about TCP positioning. It's going to be a good step forward. Thank you. Thank you very much, all folks at Cruise and everywhere for working on TCP. It's great to see that you keep momentum, that this is moving forward.
Yeah. Thanks, guys.
All right.
Thanks for the
attending,
discussion.
everyone.
Thank you.
Bye.
Thank you. Super exciting.